So could you make like a short description of what is new in the refactoring and like what new functionality or what difference we have now?
Sure. So the refactoring actually wasn't oriented around adding a lot of features. It was around changing a lot of the internals and specifically removing a dependency on this library called Hedgehog that we used for prototyping. So before we were using this Haskell property-based testing framework to do a lot of the heavy lifting on our generation and execution of tests. But as it turned out, that wasn't really optimized for use cases like ours. And so it ended up having some performance downsides, and it made it harder for us to extend the framework in some direction. This is specifically to do with viewing call sequences that introduce a test failure. So what the refactor was set out to do was just remove Hedgehog as a dependency. On the way there, it added this notion of a campaign and redid the CLI user interface, but there isn't a lot of new features. It's more just about cleaning up the internals, making it faster, more reliable, and easier to debug. Hopefully, if you've been using Echidna before the refactor, you can continue using it with minimal changes at the CLI. And if you're an API user, then I'm pretty confident that the new code should make it way easier to write more powerful scripts. So that being said, like I said, I want to do this as more of a Q&A format, ideally troubleshooting problems that you all have, rather than just a presentation type thing, because a lot of this, a lot of what's new is fairly deep in the Echidna internals, and you might not even have the context for it unless you've been doing Echidna API scripting. So that being said, does anyone have questions about how to use Echidna for their use case? Maybe some issues they've been having trying to get it set up, feature requests, or questions about some design decision, or I really wish Echidna would integrate with some other thing.
I have a question.
Yeah.
Why did you decide to, what was the design decision for like making it so that you had, so the contracts must be constructed with no argument constructors and not allowing Echidna to pass in arguments to constructors for contracts?
Yeah, happy to answer that. So to be entirely honest, it's mostly just because I wasn't sure what the best API was for users passing arguments to constructors, particularly at the CLI. So the vast majority of our users don't know a lot of Haskell. They don't want to dive into the internals. And they certainly don't want to debug weird errors. So I could either implement Solidity parsing at the CLI and then like parse source errors and send them back to the users, or I could just ask the users to do a bit of Solidity dev, which they're presumably already familiar with if they're using this tool, and achieve the same kind of results I'm looking for. I can say that personally, when I use Echidna on assessments, I usually am already writing a fairly large custom constructor. That's how I do stuff like setting up multiple contract interactions, like bringing in libraries, like setting up my initial state. And so just adding the arguments there feels pretty natural, although maybe I should more explicitly document that pattern. Does that answer your question?
Yeah, for sure. That makes sense.
I've actually been in touch with one of the authors of HEVM, the library that we use for the kind of execution internals, about adding functionality to fuzz contract constructor arguments or explicitly provide them. There's a kind of dead-ended PR at the bottom of the Echidna pull requests list right now that implements some of that. So it's not a thing that I'm close to doing in the future, but I would have to hear from some users about a compelling use case where the current modus operandi is somehow lacking.
Gotcha.
Great question. Anyone else? I mean, if no one has questions, I can just talk about some of the internal differences until someone does. But
Yeah, I have a question actually.
yeah,
How far are we to have the possibility to have a setup where we can just deploy multiple contracts prior starting to fuzz without using a constructor as a deployer of contract?
so we've always had weird correctness bugs around deployment and construction and stuff that happens at construct time, because basically every EVM implementation does. I think that right now you should be able to spin up multiple contracts from the constructor of a contract. And if that fails to work correctly, that's not shocking to me, but please open a ticket and I'll do my best to triage it and figure out if it's a HEVM issue or an Echidna issue. What I'd really like to do is have command line multi-contract support. It's been a long-term goal of mine because I feel like it'd be really excellent for Echidna. And I think that on the functionality side, we're actually getting pretty close. The big refactor introduced a transaction type, and that transaction can be a create, and it should work correctly. Again, if it doesn't, that's not shocking to me, but please file a ticket. So I think the hurdle between us having good command line multi-contract support and right now is primarily just that we need to figure out the UX and kind of the developer workflow for specifying how multiple contracts should be loaded. So I've looked into using something like migrations that Truffle does. I don't love doing that. I don't really want to have a mixed Haskell JavaScript Solidity project, because I feel like if you do that, then like the earth opens up and you fall straight to hell. I've looked into just making deployment go to predictable addresses, which are specified at the CLI, and I've documented defaults, and I think that's the direction I'm currently leaning. But it's been in the works for a while. Definitely a priority. I think happening soon.
Cool, thanks.
Any other questions? Happy to take more, or I'll just talk a little bit about what happened with this giant refactor. So, let me figure out where the best way to start is. Here, I'll just pull up some stuff. And then I'll share my screen. And yeah, at any point, feel free to interrupt me with specific questions you have about Echidna, particularly if you're trying to use it for some contract and it's not working for you. I'd really like to get those taken care of. All right. Sharing my screen now. Can everyone see this?
Yep.
So I think the biggest change is there are two files that I feel like exemplify it. Right now I'm in lib/echidna/campaign.hs, which defines our type for a fuzzing campaign, as well as functionality for stepping it forward. So what a campaign is it's a list of tests, each of which has a state, and then it possibly also tracks coverage. If at some point I'm accumulating other results in the course of a campaign, then I'll make sure to get that in this type too. But as of right now, it's just stateful tests and coverage. Test state is also pretty simple. You say that it's either open in that we're still trying to solve it. We've made some number of executions and none of them have solved it yet. We've solved it, but it needs to be shrunk. I call that large. I'm not sure that's the most clear nomenclature, but if anyone has better suggestions, happy to hear them. And then there we track the number of shrinks, because our shrinking logic is about the same as our fuzzing logic. We just try a ton of random stuff until we can observe something working. Then we keep the working thing and keep trying random stuff until something also works and is smaller.
Hey, sorry. Do you think you could increase the font a little bit?
Oh, for sure. Sorry. Is this more legible?
Yeah, thank you.
No problem. So we keep track of how many times we've tried to generate smaller call sequences so that we know when to stop. And then we keep track of our current best call sequence, which is just a list of transactions. Previously, Echidna's logic actually didn't happen at the transaction level, it happened at the function call level. So we more or less just treated everything as the call data for some transaction and then hacked together a bit of sender and recipient logic on top of that. Now we actually have not a full transaction model, it's still definitely missing some fidelity versus an actual EVM implementation, but a much richer one, and one that I think is very extensible if we later need to start keeping track of things like nonces or signatures or anything. I think that we can hack that onto Echidna pretty quickly, whereas before it'd be very ad hoc and fragile. Anyway, the third test state is some tests have passed. They're open, but we've tried enough times that we know we can't try anymore. So we presume the test is good and say it's passed. We don't need to worry about it anymore. It's solved. We're done shrinking it. Or it failed. Our execution encountered some random exception. We should still keep track of failures, but we can't really test it anymore because something is broken. So now this looks pretty Haskell-y, this update test logic, but I think the documentation makes it a lot clearer what happens. So what we do is we have a rule for given an initial VM and some test and state. We can update it with a couple rules. So sometimes it's unsolved and we want to solve it. So if it's unsolved and we want to solve it, then we give it a sequence of calls and the VM after those calls are evaluated. We could just evaluate that ourselves, but then every time we update an individual test with some sequence of calls, we'd be evaluating all of them. So we just do all the call evaluation in our campaign and pass the finished VM to our updater to save work. So with that being said, there are several rules for updating. This is kind of the more complex logic. But one of the rules is that if we have tried enough times to to make a test fail or to shrink a call sequence, then we give up and we say that it's done. We don't need to worry about doing any evaluation on this test anymore. Let's stop. Another thing that we can do is, given a sequence of transactions and the VM state afterwards, we can check that VM state to see if our test is still passing. We only need to do that if it's open. So if it's open, we check if it should still be open after these things are evaluated. And then if it shouldn't be, then we close it, I guess. Same thing for if there's an exec exception. And then the last thing that we do is if the test is unshrunk, if it's still large, we can shrink it. So shrinking, we actually do the evaluation locally because there we're not generating just a random list of transactions. We're generating a smaller version of an already known list of transactions. So that's a little bit complicated, but hopefully this list of steps clarifies it. Stop me if I need to go back at anything. So then all our campaign really does is it takes turns stepping the first, while any open tests are out there, it generates a call sequence and sees if that call sequence lets it update any open tests. Once it's failed all the tests, or we've hit our test limit, it goes to the next step right here, which is just we shrink anything left that's large while we haven't tried as many times as our shrink limit. Then once that's done, we just return the campaign state. So if you're writing a program that uses Echidna as a library, you can use this campaign function to execute a fuzzing campaign against any kind of Solidity contract you want, and then get back the results after. So eventually, once we get stuff like coverage optimization working again, we're going to use this campaign iteratively and save intermediate results. Before, with Hedgehog, we couldn't really introspect on the results of fuzzing at all. We just got to run a fuzzing campaign and show the user the results. Anything past that was ad hoc and had to involve like sketchy string parsing stuff. But now we're actually able to do higher order logic around these kind of fuzzing campaigns, which I think is going to be really nice for development. The other big new file that I wanted to show is transaction.hs. I mentioned earlier that we have a real transaction model now, which I think is another thing that could let consumers of the Echidna API do a lot more than they have before. So transactions now, instead of just being call data, can be either a call transaction or a create transaction. And we handle both correctly at execution. So if you want to write a custom fuzzing campaign that includes sometimes creating new contracts, that's finally a thing that you can do. We also obviously track the source and destination of each transaction and its value in Ether. To be clear, I don't model everything the yellow paper says in a transaction here. I'm open to doing so eventually, but haven't needed to do so far, so I haven't gotten around to it. Gas costs, nonces, and signatures would all be good things to add. So then, with this transaction, we have the ability to model a whole world. Previously, the very limited transaction model meant that Echidna was fundamentally modeling a world with about one sender and one receiver. We could hack on some extensions on top of that, but it wasn't really built to model a complete universe of contracts. It was simply built to model one contract under test, and everything else was an afterthought. But now we can keep track of our whole world, which consists of senders, or human addresses in the more conventional lingo, and receivers, which is contract addresses and program addresses, and those keep track of their ABI internally. So now when you have this world type, you don't have to go figure out something's ABI. You just point your fuzzer at that address and it works. And this lets us do things like generate random transactions that are aware of this world and automatically generate the right thing, that can use dictionaries. We're still merging dictionary support, but once that's in, it's going to make Echidna radically faster on a lot of workloads. We've been benchmarking against Harvey, that fuzzer from Consensus that claims to be pretty smart, and I think we pretty much blow it out of the water with dictionary support. Plus really naive constant extraction. So keep an eye out for that to get merged. Should happen this week or next. And then not only do we shrink the call sequence itself, we shrink the whole transaction, which is pretty nice. These transactions are actually also separate from the environment in which they execute, which is kept track of in exec.hs. So we can build all our transactions at one layer of abstraction and then execute them with or without coverage or with some particular instrumentation or special rules or hooking or whatever else on this different layer in exact.hs. This lends us a lot of flexibility to do things like explore different coverage strategies, because now we're not just executing a call. We can set up a transaction and then choose whether we want to use our execution function that just tracks point coverage, that tracks this fast heuristic coverage of just PCs. We can do things like tracking full arc coverage. So we track both the starting PC and the ending PC at instruction level granularity if we want to figure out really fine-grained edge coverage stuff. It really hasn't been added to the CLI with default options yet, because like I said, still working a lot on UX. Want to make sure that everything is simple and easy to use and intuitive. But we have all the code in here already for doing coverage guided fuzzing a la AFL. And I think once that lands, that could be another thing that really helps out with a lot of people's workloads. So that's a quick overview of what I thought the highlights of the big new Echidna refactor were. Are there any questions or things that I could go into more detail about?
Does anyone want to get lunch?
Maybe.
Yeah, I could find some more stuff to talk about for 5 minutes. Is this scheduled till 12:30? Maybe I'll talk really quickly about some other Echidna testing tips that I need to document. There's an open PR for, but haven't been documented as well. So one thing that I recommend that a lot of people do is, like I was saying earlier, you can put a lot of logic in the constructor, and then a lot of setup there, a lot of multi-contract initialization stuff, a lot of initial state. And then that lets you keep track of that in Solidity rather than having to write any Haskell, which for most people is far, far easier. You can essentially just run a list of transactions there that happen as a precondition to your actual fuzzing campaign, plus manually modify state variables, environments, whatever. As an addendum to this, I typically believe that the contract that you test in Echidna should inherit from the actual code that you own. So if you have like my token and you're testing it in Echidna, you shouldn't just add some Echidna tests to my token. You should have a class called like Echidna my token that inherits from my token, keeps all of its methods, and then adds some new tests and probably some new constructor logic. This is nice because now you can keep that in CI and source control. You can share it with your coworkers. It means that your tests can now live in the master branch of your GitHub with everything else, just like .t.sol with Truffle. Once you've done that too, you can also start adding non-test functions to this Echidna contract. Like, a lot of people want to have some randomized state. So maybe there's a market you're tracking that goes up and down. It's really easy to emulate that in pure Solidity by in your Echidna test contract having like two functions called like market goes up, market goes down that do that. And now they'll just get interspersed randomly in call sequences and affect state, just like you'd expect. Or you can do things like person A transfers tokens to person B. And now you're not just limited to the kind of logic that happens at the very edge of your API boundary, where people call functions that are well-defined. You can now modify underlying state changes. You can modify privileged users taking certain actions. You can, there's really a large space of stuff you can do with these custom setters, particularly if you make space for them in your constructor. So you can even do things like have whole new state variables that your Echidna tests take into account, are modified with special Echidna functions. And then you ensure these kind of higher order correctness properties of your underlying, of the logic you're actually testing by calling that logic on these state variables in your tests. Also worth mentioning, because a lot of people don't intuitively know this, if you do any state modification in your tests, that state modification doesn't happen in your campaign at large. It only happens in the scope of the test being evaluated. So if you want to have a contract self-destruct every time you check some Echidna test, that's fine. That self-destruct will never propagate back into other test states or call sequence or whatever, as long as it happens in the body of an Echidna underscore function. It should stay completely isolated there. Okay, so that was my Echidna tips. Does anyone else have questions? If not, I think I'm going to wrap 2 minutes early.
When are you going to cut a release of Echidna on GitHub?
We are supposed to have automatic releases. I need to go fix that. That's not on my list for this week, though, is figure out some ad hoc release processes and get ready for version numbers. We're all really excited to get Echidna some like version numbers with API stability guarantees. It's going to be crazy.
Yeah, good.
Any other questions?
So just wanted to say that we have several PRs that we're working to improve Echidna. We have dictionary support. We have different interfaces, user interfaces. We have improved documentation. So it's going to be an interesting weeks when we merge these PRs.
Yeah, a lot of this stuff happening very quickly. Definitely keep an eye on the GitHub. Anything else? Last call. All right. Thanks everyone for coming out. Hope you enjoyed the office hours and you know how to get in touch if you have any further questions or want help using Echidna. We really appreciate our users filing good issues and do our best to get them addressed as quickly as we can. See ya.